Hey team, Derek here. Today I'm going to be introducing you to Scaffold-eth 2. I'm going to front load why and who would use this, and then we'll spend the majority of this video seeing how, because the wow moment's really once you dive in and see how quickly it lets you prototype. So this is a starter repo that does a really good job synthesizing a bunch of things you're probably familiar with, like WAGMI and VM and Next.js. And it takes the typical hackathon development cycle that you would do in, say, just Remix and maintains that speed and simplicity while allowing somebody to just as quickly work on their front end in an iterative way and then deploy the smart contracts and the front end to production by the time they're done. So that's the goal for today. We're going to tinker with our smart contract, update our front end a little bit, and then deploy both to production. Scaffold-eth 2 has out of the box a nice debugging interface, very similar to Etherscan or Remix. But like I just mentioned, the real power is that it lets you mock your front ends. And it does that by coming with a couple custom hooks. So I'm going to show both of the read and write hooks off toward the end here. So without further ado, let's get into it. They just released this CLI. The cloning works just as well. Bob demo scaffold. Cool. You can use Hardhat or Foundry. I'll use Hardhat because your docs already cover Foundry. Just something people might be familiar with. So I'm going to use the really simple coin contract that was in your docs as of like the last couple of days. But right as I sat down to press record, I noticed that you updated your Hello World to a Hello Bitcoin example, which I think is really exciting and would be a really good candidate. I'm envisioning this if you wanted to use it in the context of your docs or marketing materials like bottom of funnel as something you could pitch to developers like, hey, clone this and get started. And you could interact with like the light relay and have something like this out of the box because the power is skipping a bunch of that setup time, right? Okay, we've got our repo. Let's get in. So first things first, since I'm using Hardhat, I'm going to go ahead and start our local Hardhat chain. While that's going, I'm going to grab my smart contract. Let's take that smart contract and put it in our Hardhat contracts. To keep things quick, I'm just going to be overriding the your contract.sol and corresponding deploy script. But if we were trying to be more robust, we would just add a new contract and make a new deploy script. So let's go ahead and change our deploy script slightly. We're not going to need this. Or those. We're just looking to deploy it when we run yarn deploy. It's going to go ahead and compile for us. And then this is where it gets really fun. Let's start our front end. So we'll go over to our debug contracts and see our read and write functions just like you'd expect if you're familiar with Etherscan or other block explorers, and check out how our contract works. So this is a simple token contract. My burner wallet that comes right here in the browser has none. So let's go ahead and mint some for it. Oh, I don't have any gas. Well, on my Hardhat chain, all I have to do is grab some funds from my faucet. Once those are ready, I can click send. It shows a transaction receipt right here, which is really useful for the debugging process to get a sense of what's happening under the hood. And if you're looking really closely, you'll notice that I commented out this require message.sender is the minter. Let's put that back and deploy again. So right now in our deploy script, the deployer and the message.sender is the account 0 in Hardhat. So to make my life easier for now, I'm going to copy this burner wallet address and hard code it as the deployer. If I redeploy the contract, then here on the minter page, we'll see if this updates to be the OXF5 that matches our burner wallet. And there we go. So now that this is the official owner, I can mint some tokens for myself. Now, that's all normal smart contract debugging stuff. We might add some functions or tweak them and do this iteration loop. Where Scaffold-eth really excels, though, is when you start playing with your front end. So if you're familiar with Next.js, we're doing the app router, and so we're going to modify our page.tsx at the root level. I'm going to go ahead and copy some examples here that'll show off some of what we can do. So a couple changes, some state variables, and most importantly, we're showing off the custom hooks use scaffold contract read and use scaffold contract write. As soon as I save, my front end is going to hot reload and show us the other powerful thing we get out of the box with Scaffold-eth. They're custom Daisy UI components. These are really common components in Web3 use cases, like for example, this address component that does truncation and has a nice copy button. It'll even resolve an ENS and show the logo if there is one, like the PFP. And then an address input that in the same way can resolve ENS addresses. And an integer input, this one's really nice because it'll have the multiply times 10 to the 18. Very common with smart contract work that you're frustrating yourself by having to convert between WAY and ETH. So those are a few things that I wanted to show off. It could obviously be a lot prettier, but in the context of us playtesting this mint contract, we see that to read in our minter address, we are using this custom hook on our smart contract. And similarly to write to it, we are using this custom hook and passing in a couple arguments. Where I think things jump even one level more impressive with Scaffold-eth is that it makes it really easy to go from this localhost testing to deploying to production for the smart contracts and the front end. So to do both of those things, I'm going to make a couple tweaks to our config so that it knows about Bob testnet, and then we're just going to deploy. First up, we're going to go to our Hardhat configuration and make some tweaks so that it knows what network to deploy to. Let's tell it about Bob. This testnet is going to have our URL and our accounts. Now you might be wondering, we haven't put in like any local environment variables. It's so gentle and wants to get us off to the races so quickly that it even provides default RPC APIs, deployer APIs for Etherscan. So, of course, you probably would want to change these things in practice, but the fact that it has these from the get go, I think, is a really good design choice and shows that they're thinking about iteration speed at every step from the first thing you type in the CLI all the way to production. So that adds our network. And last thing is I'm going to set myself up later when I do the contract verification by modifying this hard hat verify part. There I just added a custom chain for the Bob testnet and told it about the URLs it's going to need. So that's it. Hard hat now knows Bob exists as a network. Let's see if we can't deploy to Bob. Everything I'm about to do is documented very well in the Scaffold-eth documentation, both for deploying smart contracts and the next app. It's also got really good explanations of everything I've said so far. And I only wanted to highlight that because I think the ecosystem of support for this tool is pretty impressive. So let's see if we can't deploy. As it tries to deploy to Bob, it's going to say, wait a minute, I don't have any gas. Insufficient funds. Well, that's because it's trying to deploy from this burner wallet. So there are two approaches you can take here. What people usually do is input their own private key in an account they're comfortable with in their environment variables and do it from there. Since I'm assuming you've done something like that before, I want to show off the other way to do it. One thing we can do is run our generate script. That's going to create a private key unique to this project and generate a public address for it. This is about to be our deployer. As I send some Bob testnet gas to it, I'll show off this yarn account, which checks the block explorer for every single chain that the repo is aware of and reports the balance and nonce for it. So I've got my Bob testnet loaded up, and I'm going to send some gas to that account. Shouldn't need too much. And that's going to make the account that we just generated, which is different from the burner wallet here in the browser, it's going to make sure it has enough gas to be able to successfully deploy. So that looks like it confirmed. Let's try the command again. Oh, we got our transaction hash, and we're out there. One way we can confirm that it worked is to go over to the Bob Explorer and see the receipt and see that the contract is in fact there. And sure enough, it is. Let's verify it so that we can see its read and write functions like we'd expect. That took me a second. I think I figured it out. Let's verify. I'm going to use hard hat verify. And I have to pass in the deployed smart contracts address and any constructor arguments we gave it, which we did over in our deploy script. Now, if that all works, then when we go back over to the block explorer, we'll see that the contract is verified, and we can see its exposed functions. This is one of the reasons I think this repo could be pretty useful for the Bob community, because a lot of this setup, like the chain ID and the URLs for verification, can be done in a Bob-specific repo ready to clone. There's only one thing left I want to show, which is the front end. We already showed off a few of those custom components and custom hooks, but you'll notice the front end's still looking at the hard hat network. So the last two steps are, I'm going to show how to update it to the Bob network, and then how to deploy it. In the Next.js package, we've got this scaffold config. Now, what I'm going to do here is a little bit of a hack. VM doesn't know about Bob testnet, so I'm just going to put it right here as the target network we're using. I think it wouldn't be too hard to submit a PR to the VM codebase. They have a contributor guide for how to add new networks. So this is the kind of thing that all repos that use VM could have in the future. So now that we're looking at the Bob network, we are actually pointing at the live testnet. To save time, I'm not going to play around with our front end anymore, but I am going to show what it looks like to deploy. Yarn vercel is our command, and if you don't use the prod flag, it'll go to a preview branch, but for a simple demo, I'm going to go straight to production. If you've never used the vercel CLI, it'll ask you to log in with GitHub here. And it's going to take a moment to build and deploy. And a couple minutes later, done building. Let's check it out. So vercel, of course, just looking directly at the GitHub repo, and whenever we push branches up to main, it's going to automatically do its CI/CD and have those live. And we've even got our URL right here for the front end live. So that's it. Smart contracts and front end, from playing with them all the way to production in just a few minutes. I think this is an essential tool for any ecosystem trying to attract new builders, because the iteration speed is unparalleled, especially for beginner to intermediate devs looking around at other successful protocols like Aave and Compound and thinking about, well, maybe I can fork that and try it out on some new L1 or L2 and make it my baby. If I were going to continue this, I would swap out the contract for the Hello Bitcoin example and go around showing off what it can do with the ordinals and ERC20s and wrap Bitcoin or other, Bitcoin proxy, because I think that's the unique proposition that Bob is offering compared to other L2s in the OP stack. This is the kind of tool that I think makes it possible to show devs who really like to see these demos how easy it can be to deploy on Bob, and then mix that in with some of the biz dev explaining Bitcoin L2 Renaissance, the ability to interact with Bitcoin, and a quick explanation of merge mining. And I could see this being the kind of thing that drives a campaign around developer adoption for folks already familiar with EVM and really interested in the kinds of things they could do on Bob. Happy to dig in more with some of the things that make Scaffold-eth unique, but I hope this did a good job capturing most of its main drivers of speed: the custom components, the WAGMI hooks, and the ability to take smart contracts with Hardhat or Foundry, and the front end from iteration to production in literally like half an hour if you already have ahead of time a plan of what you're trying to do. All right, I look forward to chatting.